Okay, today we are going to be going beyond CPCTC, and it's from chapter 3.4 in your books if you want to follow along. Okay, so our objectives for today will be to identify medians of triangles, to identify altitudes of triangles, to understand why auxiliary lines are used in some proofs, and to write proofs involving steps beyond CPCTC. By the end of this unit, you will be able to say CPCTC 10 times quickly. All right, so let's start off with medians of triangles. We have three medians shown below. Segment AD is a median of triangle ABC. Segment EH is a median of triangle EFG. And segment FJ is also a median of triangle EFG. Now notice something about these medians. It's from a vertex of an angle to the opposite side. And at that opposite side, if you notice how each time on the opposite side we've got these hash marks, that means it's to the midpoint of the opposite side. And that would be extremely useful because then you can say that this segment is congruent to this by the definition of a midpoint. So something to keep in the back of your mind. So again, here's the definition for you. A median of a triangle is a line segment drawn from any vertex of the triangle to the midpoint of the opposite side. So again, something that will come in extremely useful in your proofs. Okay, let's move right along to altitudes of a triangle. So we have the diagram below, and AD, segment AD, and segment BE are altitudes of triangle ABC. Now what do you notice about these? We have these little marks here. What does that mean? It means they form right angles. So an altitude is different than a median because an altitude is from a vertex and then it forms a perpendicular segment to the opposite segment, the opposite side. Okay, so this forms a 90-degree angle. Again, an angle measurement that could come in handy. Now, every triangle has three altitudes. It should also be mentioned that every triangle also has three medians, but every triangle has three altitudes. So here's one from one vertex to the other side. Here's another. BE is a altitude. And which one are we missing? Well, if you go to angle C here, from this vertex to the opposite side, which would take us somewhere around there. I know it's not perfect, but you get the idea. Okay. The point I want to make here is altitudes don't necessarily cross in the middle like a median would. So that's a major difference from a visual standpoint. So this third altitude would be, if we had to label it, we could say that segment CF is also an altitude of triangle ABC. Okay, so the definition. An altitude of a triangle is a line segment drawn from any vertex of the triangle to the opposite side, and in parentheses, extended if necessary. I'll show you what that means in a minute. And perpendicular to that side. So look at this triangle here, and what are the three altitudes of triangle ABC? Well, now we haven't exactly gotten into the types of triangles yet, but you notice that this has a right angle down here. When you have a triangle where one of its angles is a right angle or 90 degrees, you're only going to see two altitudes easily. Okay, what happens is you've got one altitude, segment BD, and then the other two are actually sides. So segment CB is an altitude, and segment AB is also an altitude. So something to keep in mind with right triangles, two of the sides of the triangle will actually form the altitudes. Okay, now this is what I was talking about before. Sometimes you have to extend the triangle to draw the altitudes. So we have our first one, which is really easy to see. We've got from angle A and then to this side BC, it's perpendicular. So segment AD is perpendicular to segment BC. That's one of the altitudes. But now the other ones, to actually form, we would have to extend this triangle out a little bit, like so. And now if you notice, it forms a right triangle. So segment BE is an altitude, and segment CE is also an altitude. So again, something to keep in mind. When you have this type of triangle, sometimes you have to extend it out a bit. All right, now auxiliary lines. You're not going to be using this a whole lot, but it is good to know. So if we took a look at the following problem, we're given that segment AB is congruent to segment AC. We're given that segment BD is congruent to segment CD, and we would need to prove that angle ABD is congruent to angle ACD. That'd be really easy to prove if we had a segment that joined these two right here, because then we could prove these triangles congruent by side, side, side. And then since we had proved the triangles congruent, we could prove that the angles were congruent by CPCTC. But we don't have that line. Okay, so with the information we have right now, we couldn't prove it. However, we could use a postulate to help us out here. And that postulate is 2 points describe a line or segment or array. So this is called an auxiliary line, which connects 2 points already in a diagram. So you can use this in a proof, but you actually have to state it. So go back to the proof. We're given this proof. Start it off like you normally would. Segment AB is congruent to segment AC. That's a given. Segment BD is congruent to segment CD. That's a given. And then we would say that we would just simply state segment AD. And notice that this line appeared. Okay, and we could say that because 2 points determine a line. So you would add it in and give that as a reason. Now we can say that segment AD is congruent to segment AD by the reflexive property. And we can prove that triangle ABD is congruent to triangle ACD by side, 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 steps 1, 2, and 4. And because we've proved the triangle congruent, now we can say that angle ABD is congruent to angle ACD by CPCTC. It's a heck of a lot of letters. Okay, so finally, I'm going to give you guys a bit of a challenge proof that includes altitude and median. So we're given that AC is an altitude to BD. We're also given that AC is a median. And we also have that angle BAC, so that's this one right here, BAC, is complementary to angle D. We need to prove that angle DAC is complementary to angle B. So one thing to keep in mind, please, I notice this happening a bit on the quizzes. Before you can use CPCTC, you must prove that the triangles are congruent. You can't do that until you use one of the theorems, side, angle, side, 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 angle, side, angle. So you have to prove the triangles congruent first and then go to CPCTC. And then there's actually a couple steps after that. So this is a longer one. I'd say somewhere in the area of 8 or possibly 9.